So, we know that if we can find the vertex, we can graph it, but there's other things, reflection, dilation, that we also have to worry about. So let's not forget, the rule for multiplying the function by a negative is still the same. It makes the parabola open down instead of open up. We're multiplying by a negative outside, so that flips it vertically. We mentioned that flipping horizontally doesn't matter because it's a U and it looks the same either way, but we are interested in that vertical one. The other thing is dilation. If a number is multiplied by the outside of a function, you remember it changed what it went up. Okay? So if our pattern is normally over 1 up 1, over 1 up 3, over 1 up 5, instead of going up 1, 3, 5, we'll have to multiply that 1, 3, 5 by that number. So let's look at an example. So we have y equals 2 times x minus 3 squared minus 3. So the first thing I'm going to notice is that my vertex is 3, negative 3. Opposite of the inside number, keep the outside number. Normally, I would then go to that point, over 1 up 1, over 1 up 3, over 1 up 5, go the other way, over 1 up 1, over 1 up 3, over 1 up 5. But this time it's going to be different because we're multiplying it by 2. So I'm going to go over 1 up 2, over 1 up 6, over 1 up 10, because 1, 3, and 5 all got multiplied by 2. So I have 2, 6, 10. If I was multiplying it by 1/2, 1, 3, 5 would get multiplied by 1/2. If I multiplied it by 5, 1, 3, 5 would all get multiplied by 5. It's still the same pattern, it's just getting multiplied by something. Alright? Now, it's not always given to us in graphing form though, so we can't always use the transformations. So we need to make sure that we can find the vertex when it's in standard form, because we're still going to need to graph it. So don't forget what standard form is. Ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x, and then c is the constant. And we have a shortcut. I'm all about some shortcuts. The x-coordinate of the vertex is always the opposite of b. That's what negative b means. The opposite of b. Divided by 2 times a. So the opposite of b divided by 2 times a. The y-coordinate is whatever you get when you plug the x-coordinate back in. So once we figure out what the x-coordinate is, plug it into the equation and figure out what your y-coordinate is. So let's look at an example. If I needed to find the vertex of this equation, 2x squared plus 8x minus 7. Don't forget, a is the number in front of x squared, b is the number in front of x, and c is the constant. So if I am looking for my vertex, I need my x and my y coordinate. So x I know is going to be the opposite of b over 2a. So the opposite of 8 is negative 8. 2 times a, 2 times 2 would be 4. So negative 8 over 4 is negative 2. Plug negative 2 in. Negative 2 squared is 4. 4 times 2 is 8. Negative 2 times 8 will be negative 16. And then we have minus 7. And so we end up with 8 minus 16 minus 7 is negative 15. So that would be my vertex when it was in standard form. Now, the whole point we said of algebra was so that we could model situations, we could use data to get the information that we need, and we did that with linear last unit. We did linreg, stat edit, stat calculate, put all the data points in, then make a straight line. The problem with that was just linear. We know not all points actually look linear, but we can still find models for them. That's why we learned the other functions. So let's take a look at this particular set of problems. Let's get our calculator. And we're going to go to Stat and Edit, and looky there. We've got all our points plugged in. We've got our x's in the x column and our y's in the y column. And I want to look at these because, again, now that I have options for functions, I only want to choose a straight line if the points look like a straight line. I only want to choose a quadratic if my points look like a quadratic. So if you go second y equals, it takes you to the stat plots. And if we turn stat plot on, I can choose to turn it on. I want it to have a dot plot. I want to use list 1 and list 2. I can even choose what the dots look like. And then I can go to y equals and make sure I clear out anything that's there. And then I can go to my window. You want to make sure your window fits. My data went from 0 to 10. So I'm going to make it go 0 to 10. And then it went from like 0, I think the biggest number is 30. So if I make my y minimum 0 and my y maximum, not 400, how about 35? That seems reasonable. And then graph it. Look at that. Those points do not make a straight line. They are definitely quadratic. So I want to make sure that I find a quadratic model. It is no different than when we found linreg. I'm still going to go to stat. Still going to go to calculate. Just notice that the choice under linreg is quadreg. It's quadratic. It's the same thing. It'll find the quadratic for us. If we hit enter, notice y equals ax squared plus bx plus c, so it's giving us our answer in standard form. A is -1, b is 10, and c is 5. So that means that my equation is y equals -x squared. You can put the 1, you don't have to put the 1, plus 10x plus 5. And that is the model. Don't forget, the model is the equation. The model is our predictor, our fortune teller. This is our model. Now, if you ever want to check it, don't forget you can turn the diagnostic on and get the r squared value, but you can't always go into y equals and type it in. -x squared plus 10x plus 5, and take a look at the graph. Look at that. It hit almost all of those points. I would say that that is a pretty good model. All right? So that's how we deal with modeling with quadratics. Now there's a couple of things that you need to know about all of these parts of a parabola. In a word problem, they actually stand for something. What do they stand for? So using a model in context. The first big one, the vertex is the maximum or minimum. If you see a problem and they give you a quadratic equation and you know it's quadratic and they ask you to find the maximum, find the minimum, maximize, minimize, that is telling you you need to find the vertex. They're not going to say in the problem, find the vertex. No, they're going to ask you maximize this situation. What is the maximum height? What is the highest they reached? What is the minimum for this problem? Maximum or minimum means the vertex. Other important points. The y-intercept is our starting point. Remember we said x is almost always time. So if time is 0, no time has gone by, that's the starting point. So the y-intercept is a starting point. X-intercept, it's generally a solution if you're trying to solve for x. It's where y is equal to 0. So any situation where whatever you're dealing with, the y is supposed to be 0, you would use it. The most common quadratic function is things dealing with gravity. Acceleration, gravity is a type of acceleration, is quadratic. And so anything that involves dropping something or throwing something up in the air, these would be quadratic functions. And so generally, height is the y value. So where is height 0? The ground. So if y equals 0, if height is the 0, then the x-intercepts are where these items hit the ground. If somebody drops out of a plane, the x-intercept is where they hit the ground. If I throw a ball up in the air, the x-intercept is where that ball hits the ground. All right, so those are some situations in context and the points that they represent. So let's look at a problem. The height of a toy rocket launched at an initial speed of 160 feet per second, t seconds after being released, can be modeled by the equation h of t equals -16t squared plus 160t. There is a reason I love quadratic word problems, and the biggest reason is they give me the equation. Guys, last unit you were so stressed out by those systems of equations because you had to write the equations. The quadratic problems, they give us the equations, so we don't have to figure them out, and that's a big bonus. All right, so what should I do when I first get this equation? Well, let's look at the questions underneath. That's usually a hint. So, graph the function. All right, that's what I'm going to do. Where's my handy dandy calculator? All right, when it says graph the function, folks, it doesn't mean that you're supposed to graph it on a piece of paper. It means go to your calculator and graph it. Now I do want to turn my stat plot off, so I just hit enter to turn it off, and then I type in. Please be aware you cannot use t on the calculator. You do need to use x instead of t. So -16x squared plus 160x is going to be my problem. Now if I graph it, it doesn't quite show up. I see a little bit of it over here. So get used to zoom 0. Zoom 0 is zoom fit. Ah, look at that. That's a nice little parabola. I can see that. Excellent. So I have graphed my parabola. Check. Next up, let's see if we can... What is the maximum height obtained by the rocket? Okay, two key words, maximum and height. Because it's a maximum, that tells me I am looking for the vertex. Now the problem with the vertex is it's a point. It's got an x value and a y value. So I need to know which number I'm looking for. So I look at the problem. T was seconds, and T is our x value. So y, that was our h, y was our height. So if this was my height, that means I am looking for the y coordinate of the vertex. So if you remember, opposite of b over 2a is my vertex. So the opposite of 160 would be negative 160. 2 times negative 16 is negative 32. And you may be asking, Ms. Parker, isn't there a maximum minimum function on the calculator? There is, and it is much more confusing than me just typing in negative 160 divided by negative 32. It takes more time. I have to set my settings on my calculator just right, and this gives me the exact number, 5. The problem is that was the x-coordinate. We said that x was our seconds. So that's not what I'm looking for. So I do need to plug it back in and figure out what y is, but this is where your calculator can be handy. Since we've already graphed it, we have a table. Go to table, boom! There's 5. 5, 400. So I know that my vertex is 5, 400. So I need to answer my question. It was just asking me for the y value. So the maximum height obtained by this rocket was 400 feet. Done. Let's look at the next question. How many seconds after the launch did the rocket reach its maximum height? Again, there's that key word, maximum. So that tells me that I'm looking for the vertex. Now what is it asking me for? It is asking me for how many seconds. So which letter was seconds in our problem? That was x. So if I go back and look at my point, the x value was 5. So that tells me that the time, how many seconds, it was 5 seconds when it reached its maximum height. Next question, what is the y-intercept? The y-intercept is where x equals 0. Plug in 0. 0, that goes away. 0, that goes away. The y-intercept is 0, 0. You could have also looked at the calculator, gone up here to where x equals 0 and looked. Oh, 0, 0. There's my x-intercept. Next question. What does this represent in this situation? Well, we said that the y-intercept is a starting point. So that tells me that this rocket started, the rocket launched on the ground. It was 0 feet off of the ground when it launched, so it launched on the ground. It wasn't on a platform. It wasn't up on a table or, God forbid, somebody holding it, because that doesn't seem like a bright idea. But it was on the ground when they launched this rocket. And when does the rocket return to the ground? So the ground, we said, was 0 feet. So if we go back to our calculator, we know we are looking for where the feet equals 0. Well, here's 1. It started on the ground. But when did it end up back on the ground? So let's go down here and see. Oh, there's another 0. So it was after 10 seconds that it actually ended up back on the ground.